Okay, so operating data pipeline with Airflow. Hello, everyone. My name is Ananth. Um, I work at Slack, senior data engineer. My work mostly focuses on the data infrastructure side. So my team manages a bunch of Hadoop clusters, Kafka, streaming infrastructure, and Airflow is one among them. So today I'm going to talk about how we really operate Airflow. This is not like an introduction to Airflow system kind of a talk. Basically, like once you have your Airflow system running and you deploy this DAGs, how are you going to manage it? Like, what are the issues that you often see, and how are you going to manage at scale? So, how many of you actually heard about Slack? Wow. How many is actually using Slack in day-to-day life? All right, nice. My job is more safe now. Okay, so brief history of Slack. So it's public launched in 2014, pretty new, 3.5 years old. 65 of Fortune 100 companies are paid customers. More than 500K organizations are using Slack. So other things like more than 1,000 plus Slack employees now, but we have 15 data engineers, so you could see the ratio. And we have 8 million active users on a given time connected to Slack. Data usage at Slack, 1 in 2 per week interacting with our data warehouse system at one way or other. Either they're querying it or they're creating some data pipeline out of it. And we have 500 plus tables. It's still growing. And we are getting about like 70 million events per minute, roughly around 1 million plus per second. This is about Airflow stats. We have around 360 plus active DAGs right now, and more than 11,000 tasks running every day, either a Spark job or a Hive job or some cluster queries, do some data quality checks. It's a mixed of workload. And we have 72 contributors for our data pipeline projects. So I put this number for a reason. If you go back here, we have only 15 engineers on the data side, but we have 72 contributors actually building data pipeline. So that gives a gist of the power of Airflow and the simplicity of providing a high-level language as an abstraction. So if you wanted to create a data pipeline, all you need to know SQL and a simple Python, right? So you don't need to learn any other underlying infrastructure. So it's the cost of entry is pretty low. So that's why you got like so much adoption, and we're able to democratize the data pipeline with a very small number of engineers. So agenda for this talk, I'll give a small overview of Airflow. How many of you are actually using Airflow? Okay, so I'll quickly go through a concept of Airflow, and then how did we scale Airflow executors, and some of the best practices that we follow on the pipeline operation perspective, and what we did for alerting and monitoring things. So Airflow overview, Airflow fundamentally a DAG, right? It's a set of tasks created a DAG and execute based on the structure that you mentioned to do that. So it's a graph of Airflow task, and each and every task has an operator. So the operator can have like either a sensor operator. Let's say you are writing Kafka files on S3, and some sensor operator waiting for that to pick it up and run some task on that. Or you are waiting for some external source of data comes into your data warehouse system. So there's a set of sensor operator. The job is to wait for something to execute an actual action. And that brings next operator, like an action operator, is you actually do some operations on top of it. Either you run a Spark job, you're trying to do some, let's say you're trying to do a daily active user calculations things. And there is a transfer operator. Transfer operators basically wanted to do some transformation from data from one point to another point. So examples like you want to do like import data from Salesforce to S3 is one kind of a transport operators. And the DAG and the operator has to execute somewhere. So the executors are the one who actually do the execution part of it. Airflow is a very flexible system, so you can create your own executor. By default, it's providing a local executor. What is local executor is, for every action of execution, it'll create a new Python process on your local machine and execute that. And there's a celery executor you can push job to celery queue and then get the celery to execute that one. And there is a Mesos executor, and recently they're adding Kubernetes executor for that. Right? So that's an overview of like a brief intro of Airflow concepts. And typically an Airflow UI looks like this. So a typical workflow looks like you're fetching a tweet, and then you're cleaning the tweet, and you did some analysis, and then you just fan out and execute in a different task. So this is a typical DAG looks like, and each one of the unit of execution is actually an operator. So Airflow built on top of DAGs and operators, right? So how do we use Airflow? Surprisingly, we use local executors. The fun part is like local executors initially created to test Airflow scheduling engine. It never meant to be a production system. But we use Airflow local executor. So the fundamental thinking behind that, we should introduce any new component only if necessary. Any new component that you added to a system, you're increasing the complexity of the system. So we wanted to minimize can we solve a problem in a single machine? Will give much more scalability than introducing a distributed component system, right? So using local executor, I'll talk about how did we scale local executor. So the deployment is a tarball-based deployment, and someone merged the code into the GitHub masters, Jenkins, build it, create a tarball, deploy that into Airflow box, and restart the systems, right? We use Flake8, and PyTest to test it out and maintain all the code quality, other things. The other thing we created, a shell utility, Airflow. So any developers can use the Airflow shell utility, and they can test their DAGs locally within the system before pushing the code into the production. So this utility gives a lot more flexibility. So anyone want to contribute to Airflow repo, they can test everything in local. So that gives a lot more confidence for them to add more DAGs and become more comfortable to developing the systems, right? So this is a rough overview of Airflow infrastructure, Slack. So obviously, the local executors will not scale at a certain point because you can spin off only so-and-so process in a single box. So initially, when we started using Airflow, we had no clue what is going on. So usual terms that we started to discuss is like, oh, just Airflow being Airflow. There was a lot of confusion around like, why my task is not running, and like Airflow is a deadlock is going on, why this task is not scheduling. So much confusion going on. So we started to look into profile the CPU things. So if you look here, the CPU is so fine, the idle state is really nice, but right about 4 p.m. UTC, that's a midnight UTC, there's a 4 p.m. PST time, the CPU started to hit a hard. What is happening here is we have a lot of daily jobs waiting for the daily snapshot to be arrived from our operational data store. We use MySQL as our operational data stores. So there is a process taking a daily snapshot from MySQL and then getting to S3. So there's a whole bunch of daily jobs needs to run that just keep waiting for the task to arrival. And that's really hit the CPU. And so that makes Airflow not to able to schedule any other new tasks coming in, right? So now, then we started to discuss, okay, this is a problem, how can we fix it, right? Can we introduce a celery executor, or can we write our own scheduler even. So various options been discussed. Then we started to think about like, okay, how can we scale even this, right? So if you look back how airflow sensor works, the life cycle of an airflow sensor is very static. What it means is that, let's say you wanted to start a job at 4 o'clock, it just start, and it's keep waiting for the files to arrive. So it just keep occupy the CPU cycle, and it's not doing anything at all. It will not yield, or it will not die for the process to come. So just occupying some slot, doing nothing, right? So we thought, okay, how can we, why can't we change the life cycle of sensors? Instead of instead of just waiting for that, you just wake up, see if your file is there. If not, just die. Now retry some time, yield the process to somebody else. So the actual task that can get executed with that, right? So that's the solution that we came up. And so we created something called multi-retriable sensors. So this goes like this. So you can create a retriable sensor, and you can wait for multiple files at a given point of a time. So this one single process, instead of creating like a 10 different process for individual things, we created like a one single process, and then it'll do all the checks, what are the files are there. If there, it succeeds. If not, we die, and then retry again and again. So once we implemented this is how our CPU idle changes. From all the way down, you see like a nice zigzag curves going on after that. These are all multiple retriable sensors. Now, what happened is that now the delta time we have enable us to schedule other tasks. So we simplify the problem within a single box, and we're able to run such a large task systems. So it's a very small tweak that save us, introducing many distributor systems onto that. So far we are very happy with whatever Airflow running on a single box. We're running on an M4 10x large, and we are running on AWS, so it's pretty cheap for us to kind of vertically scale for some time instead of introducing more and more new components into that. So that's about scaling local executors. So the pipeline operations. So most of the pipeline operation that I'm going to talk about, even though it says Airflow, it's very applicable to any data pipeline engine that you are using, whether you are using Aspect7 or like any other homegrown solution that you use, the philosophy works for you. So these are some of the Airflow philosophies, right? So the upstream task success is reliable. It is not. The biggest issue with the data pipelining or the data engineering is not an iterative system like a request-response model. You send a request, and you get a response, and you validate whether it is fine or not, and then you move on with that, right? In data pipeline or data engineering, what usually happens, you will find your issues only 10 or like 5 or 10 downstream jobs after that. Let's say you're calculating an activity, like user activity, like number of active users per hour. You wouldn't notice that you missed some dimensions, and some downstream jobs 10 lines down actually using that dimension, and they found out, hey, there is something wrong here, and then you have to go back and then fix it. So when a task says success, it never be going to be reliable for you, right? And the task remains static after the success state. So this, again, the second point is like, okay, what will happen when you find there is an issue? Then you again going to push your fix, and then you're going to rerun the job, right? And when you're rerunning the job, you have to rerun all the downstream job that basically depends on this job. So the task never going to be remain after the success state. It's going to change. So everything is a lie there. The DAG structure is static. It will never be static because business changes, business dynamic changes, new request comes in, you will add new business, unit of executions, and the DAG structure always going to change, right? And this is the biggest thing, the data quality not part of the task life cycle. Most of the execution engine, even with the Airflow, orchestration engine doesn't give a strong opinionated view on taking data quality and integrate into a task lifecycle. So it should be a part of task lifecycle. The data is as worth as if the people has to believe that we can make a decision out of the data that whatever that you are showing. If you don't have a proper data quality, there is no trust, and then the data is never going to work for you. So providing this philosophy is like how we actually fix it with Airflow, right? So we created a tool called Mario. It's a global DAG operator. So if you look into Airflow UI, what I showed back, the visibility of Airflow UI is within a DAG. It's not but we are running like a 360 plus DAGs, right? And when a task fails, like when a task has some issues and you wanted to rerun it back, the downstream jobs may spread across different DAGs, right? So how are you going to run everything? But the Airflow UI kind of limited to one particular DAG. So the biggest problem is like you have to find all the downstream job manually and then recreate and rerun it. So we created a tool, Marios. Basically, you can say like, okay, clear downstream jobs. It'll look into all the DAGs, and it'll find out what are the downstream jobs actually depends on this job, and then it'll automatically clear it and rerun it for you. So it's relatively easier for you to fix it rather than doing a lot of manual work. You can also find out what is a global dependency for a particular task, and that will give you much more understanding. If I do some business changes here, what are the downstream consumers going to impact for that, right? So it has all kind of good utilities to operate Airflow on a very larger scale. So that basically solves our upstream task success is reliable and the task remains static philosophies. So it's going to change, so we have to be prepared for that. We have to provide tools to basically handle those issues. And the second thing is we created a data quality tool. So when you're designing your task, you can define, okay, once this task completed, I wanted to run this data quality check to part of this task. If the data quality fail the task, don't let any downstream jobs run for that. So that gives much more reliability for us to be more confident on that, right? So that kind of solved this problem of data quality is not part of the task lifecycle. So we added data quality as part of the task lifecycle now, right? So the next thing is the DAG going to be dynamic, like DAG going to change all the time. Then how are you going to ensure the validity of the DAG? And we have 72 plus contributors, and not any of them have like a deep technical background. Like people don't really understand what the DAG means. In some cases, they just copy one file to another file and modify certain things and just plug in their SQL, right? So how are you going to ensure the sanity of the system? So we created a bunch of DAG policy validator in Airflow. That's one of the beauty of Airflow. Since everything is a Python, you can actually write your validation, data quality, or whatnot, right? You can write a simple Python test to validate everything before pushing into the production system. So some of the validation that we do is test external task. Let's say somebody adding a new task, and they depend on certain upstream task, and suddenly someone remove that upstream task, and this task just wait for a long time, it will never run, because there is no upstream task for it to satisfy. So we are checking, when you're adding a new task, is there any upstream task that you are depending on that? If not, fail on the continuous integration test point of itself. And test circular dependencies, because there is a multiple DAGs, there is very much chance you can create a circular dependency within your DAG, because most of the DAGs created in an isolated way. There is no coordination going to happen. And so we created a circular dependency validator, so whenever you push the job, it will check, is there any circular dependencies there? And priority weight. So that's one thing that we found out. So a lot of tasks or a lot of DAGs will have an SLA committed to our clients, right? And we try to give high priority for those tasks to execute first if you are giving an SLA. So we have a validator basically check, oh, if you are defining an SLA, you have to have a priority weight for that. And you have to be high priority weight for that. So we embed that validation on top of it. And test on failure, a lot of people may not add the alerting system into that. So if you add a high priority task, and if your task bound to production system, bound to an SLA, you have to test alert on failures, right? So we test that also, like, hey, do you have an alerting? Do you have a priority weight if you add an SLA for that? And test SLA. And if you do what we found out, like some people will add the high priority, but they won't add an SLA. So that makes no sense. If you don't have an SLA, why are you setting a high priority for that? So we test the dependencies and attributes of each and every task. And test SLA timings. There's another thing, like let's say your downstream, like your upstream task finishes like 12 p.m. and you have an SLA of a downstream jobs like 11:30, which make no sense because it's never going to satisfy anyway, right? Since the DACs are globally distributed, there is no good view on like what is my SLA going to be. So we created a validator that basically check whether the SLA timing make really sense when they're testing, or we are suggesting, oh, this could be a better SLA timing for you because your downstream, like your upstream job's going to finish only at this particular time. And we made this mandatory to have a DQ check. If you have a production weight DAC, if you have an SLA, you should have a data quality check embedded into your task, right? Otherwise, there is no point of giving so much importance to the particular task to execute things. So we test, so we run all those validation the moment they push the code, and the Jenkins continuous integration system will run all through this validation to make sure everything, the sanity of the full data pipeline maintained. So that's why these validations enable us to open to everyone, so anyone can contribute as long as you don't violate the design that we created. Right? So that kind of solve this problem. The DAC structure is static. It's going to change all the time, but how can we prepare for that? You can add these validations on top of it to make sure it's never getting violated for your building blocks. So third thing is alerting and monitoring. So when we started to create an alerting monitoring, we started to have an on-call rotation for everyone. So all 15 engineers will have an on-call rotation every week. So they manage any pager alerts or any triage requests that comes in Slack. And when we started to do that, it's all messy. Like we alerted on everything, right? Which make no sense. And like over the period of time, we found out like, why are we even alerting this, right? There is no point of paging someone in the mid of the night and for nothing, and then wasting his productivity the whole day. That waste of the productivity is too costly than the alerting that you're going to fix on the data pipeline, right? So we come up with this design philosophy. It's like, okay, how are you going to fix this alerting and monitoring? Then the alerting should be reliable. Alerting should be actionable. So if you're doing a page, it should be an actionable page. If you have an SLA for a particular DAC and the task is still running, but it misses the SLA, there is no point of paging someone because the task is actually running. Even if you wake up, you're not going to do anything because you just say, oh, okay, I validated it, the task is running, and you just go to sleep, right? So there is no actionable inside. So SLA miss is always an anomaly sometimes, may not accurately represent the state of the system. So you have to alert based on the state of the system rather than a simple SLA miss or a particular matrix define that. And alert when it really matters, right? If you have a production DAC and then have something gone terribly wrong, then alert it. If you have non-priority task and even it is fail on the midnight, don't send an alert or wake up someone, right? And suppress repeatable alert. That's one thing in Airflow. Once you started to fail a task and it will retry again, and the task fail again, it will just bomb you with all the alerts. So once you got sent one alert. There is no point of repeating so many alerts, providing the priority of the alert. So we have to suppress and send only the alerts that needed, right? So these are the principles that we took it and started to build our alerting system. So in Airflow, it has an inbuilt alerting system. What it provides it provides a callback for you. So if the task fail, or if the task retry, or an SLA miss happen, it will give you a callback to you, so you can write your own logic. How are you going to alert it, and how are you going to manage the whole alerting system? So that gives a lot of flexibility for you to plug in a component without really changing the core scheduler. You can customize Airflow doing that. So we end up writing a lot of callbacks. So this is how a typical code snapshot looks like. So we created a on-call alert callback, which is like a Python callback, basically. And you can define what is the channel that you wanted to alert. SLANL is a Slack channel. We use Slack, obviously. And priority is like, okay, what is the priority of the task? If something failed, what is the escalation chain? Because you're on call, you may not develop the DAG, but what is the escalation chain that you should go to mitigate the issue? And is there any notes that you wanted to provide for the on-call engineers to read that? And what is the resources? Like maybe there is a runbook for that. If the alert comes in, there is a runbook that you can go and follow and fix it, right? And what is a PagerDuty email for that, right? So we standardize this on-call alert callback. So if you add any SLA-specific production-critical system, you should have this callback, and you should have all those system like information to be filled it up. So that helps us to manage like all the DAGs, right? So that's an on-call alert callback. So and we all, like Airflow has a nice utility called Airflow plugin. So Airflow plugin is that you can also add whatever like a UI things that you wanted to add, or a menu or something like that, you can add that into Airflow plugin without changing that. So we created a new Airflow plugin that has, if you get an alert, oh, this is an on-call dashboard, you can see what are the tasks are failing, what are the tasks are running, what is the current state of that. And we built a new dashboard that's specifically for the production DAG, and say this is how a production DAG is running right now, and you don't need to go and look into whole messy Airflow UI on top of it. Like you just focus on the production DAGs, and this is the state of the production DAG right now. So when you get an alert, you should focus on what really matters. So the production dashboard or on-call dashboard is basically trying to figure it out where the problem is, right? And then we have a link to runbook. There's a single-page runbook that gives all the information about a task, environment, what is the critical system of it, every information on that. So we added that into Airflow UI, so you can figure it out very easily, right? So this is a sample alert looks like in Slack. So SLA miss. So the red sign means something very bad. It's failed, and it need an immediate attention for you, right? It is not pager worthy, but something gone bad. You have to look at it immediately. So this says like, okay, SLA miss on this DAG, and there is a link for the DAG, so you can click from the Slack channel. You can straight away go to the particular task run and see the status of it. And the notes says like, hey, this is a core pipeline, no downstream task will run this task, so you have to fix it right away. So it empathizes the priority for that. And escalation chain, these are the two people who are the maintainers of the DAG. These people should not be contacted unless and until you're not able to resolve the things with the runbook, right? So it will give you a link to the runbook. It will give you the information of pressing the priority of it. This really helps on-call engineers to make a decision whether to escalate, whether to solve by himself, right? And this is another sample alerts. This is a data quality warning. There are a lot of times you wanted to check the data quality, but you don't really want to alert it. Like you don't want it to fail the task. You want to know, hey, this is fine, just go ahead, but I wanted good to inform what is happening, right? So this is one of the warning that says it's failed on the DQ quality warning, and it clearly says this is not a blocking task. And failures can happen due to fluctuation in values outside the normal values. It's totally normal. Investigation this and post an update in a thread, but you don't have to clear the Airflow task. So basically says like, hey, this is normal, there's a fluctuation happen, you just go and check the database and see what's happening there, but you don't need to block the downstream jobs to run for that, right? So that's, so the notes clearly says, and also it says failed column, that what column that is actually failed. So you can go and audit a particular column for that. And again, the escalation chain, how this is a person, is a directly responsible individual for this pipeline, and he should be contacted only when needed, right? And this is another alert, which is data quality failure. In this case, it's red because it is real failure. So it says this is a core pipeline, no downstream jobs runs on that. You should not clear this task. And this is the row count, data quality is missing. Here is a triage book, customer stats run. So if the row count is missing, go and check the on-call dashboard and see what is happening there, right? So we created all this nice, good utility wrapper on top of it, and you suppress alerts. We made a very specific focus on improving our on-quality life. And this is what happened after that. It's quite in here. It's a little too quiet in here. And there's no alerts. And like everyone's so happy and like, don't jinx it. And I literally went and see whether Airflow is actually running or not. So it runs. So a lot of works that we did around improving our on-call life, alerting, and insights helped us a lot. Help us a very small team to maintain such a larger systems, right? Yeah, I think this is a summary of my talk. Keep your infrastructure is very simple. I think that's a very key things. CPU memory is very cheap in cloud world, so burn as much as possible before you actually thinking of getting into any distributed systems, right? The world will be in a much better place if you can solve all the problems in a single computer, but fortunately not. And the second thing is you don't own the platform, the users own it. This is a critical system thinking that we apply across all the Slack infrastructure. Even with the Airflow, we don't restrict anyone, how are you using it or what are you going to use it. It's pretty open, and then we enable a system level checking to make sure that the system works fine, not necessarily inducing any manual bureaucracy in the middle of it. Trust, but validate the pipeline. That comes the next thing. It's okay to trust your data, but you have to always validate to make sure that it's correct. So that's been my talk end. Thank you.
Well, thank you. And we have a nice list of questions. From C0D3 Guru, which I just learned I can call him Code Guru, which makes much more sense. He wants to know, Airflow seems limited to Python only as a DAG expression language. Why not using a generic pipeline as code workflow engine, an idea started by the contiguous integration and deployment community, e.g. Jenkins, Workflow, GOCD, Travis, etc.?
Yeah. So I think, as I mentioned here, it is more than a pipeline engine, right? It is a workflow management system. And you need to customize your system for many use cases, right? You have to make sure you're alerting that configurable, and the ability to, like, one of the biggest success of Airflow, what I see, is the movement away from creating any specific DSL. If you look at all the system, like Jenkins or Travis, whatever it is, like either you create a YAML file or a JSON file, and you force end user to learn a certain DSL specific to your domain. I think that's the biggest thing why Airflow is so succeeded, because it's Python, and most of the people know Python, and it doesn't create any learning curve on top of to learn things. So I wouldn't really call it's a limited to Python. I would say, like, even though I'm not a Python developer, I would say like that's one of the biggest success secret for Airflow.
All right. Super Mario wants to know, what are your best practices regarding testing of pipelines?
Yeah. So Airflow has a nice integration with PyTest, so all the DAGs actually testable. So you can do a local testing, and you can integrate those PyTest into the CI/CD pipeline. So once you push the code, you can run all the pipeline. That's the same way that we do. I think that's the best thing we can do now. Yeah, I think that's the best thing.
All right. Data Boy's back with another question. Isn't having just 15 data engineers out of 1,000 employees a huge bottleneck even with Airflow? Support tasks must kill you.
Not really. So that's the reason why I was talking about why it is important to think in terms of a platform rather than as a servicing, right? Like if you don't create this automation on a platform, you will end up as a servicing company, right? You are a bottleneck if you don't have this validation, and then you have to guard by yourself, and that requires a lot of manual works. So the reason why I specify that you don't own the platform, the users own the platform, is all these cases. So we're not getting a lot of support tickets. Like if you see a pattern of things getting emerged, we try to automate that as much as possible.
Okay. From Anonymous, where do alerts go if Slack is totally down? Which I think many of us have experienced.
Oh. Interesting. There is no fault tolerance on alerting so far. So we do send important alerts integrated with the PagerDuty. So all the production critical system that SLA miss, that will go to PagerDuty. So even Slack down, we still get a pager alert for that. So I think you're a safe place now.
Sounds good. Another one from Anonymous. Airflow is a product under very active development. How often do you upgrade it, and how do you ensure the stability of it?
Right. So we usually upgrade like one version behind the actual version that release. We wait for a certain time to make sure that certain fixes are working. We won't upgrade to the major version, often wait for like one major version release and then a particular minor version release. Like often you see the bugs found on the major release fixed on the minor one. And we have a test environment for Airflow. So even though we are not upgrading things, we will always run the latest version in the test environment, and we are running a lot of dummy jobs on top of it. We always test how things are working, whether it is what to upgrade other things. So the upgrading process will always go on the other side. We choose when to promote or when not to promote based on the stability of this.
Okay. Super Mario, are you Dockerizing your ETL pipelines?
No.
Easy enough. Sabiro wants to know, when do you start scaling horizontally versus vertically?
Right. So far, we don't have a need for horizontally scaling, but we are actively looking at to move to Kubernetes. The reason is not specific to scaling Airflow. We can still go like M5, and there is instance to scale Airflow. But we started to notice a pattern. Since it's a very simple Python operator, and it has a good history of things. And if you look other infrastructure operations, actually, it's kind of a DAG. It's kind of a workflow, right? You copy, and you are trying to clean up certain things, deleting some files, or even deploying Dockers images in the Kubernetes. It's another workflow engine, and Airflow is kind of fitting perfectly into that scale also. So we are looking into moving to Kubernetes, not necessarily specific to scale, but to provide more services and widen the adoption of it.
All right. For a little comic relief, Mickey wants to know, do you like DAGs?
No.
Does anyone get that reference from Snatch? Okay. Next question. Data Boy wants to know, how does Airflow compare to Uzi?
I used Uzi like 3 years back. I don't know what is the current state of it. So I can't really compare right now what is happening on Uzi side.
Fair enough. Deep Data Engineer is wondering, is your Mario tool open source?
No, not yet, but we are thinking of releasing all our checks and the tools that we build on top of Airflow so that we can add more, getting contribution for the community to add more checks and validation on top of it, but it will be soon.
All right. Continuing with the Mario theme, Super Mario is wondering, did you think about using Luigi? If yes, why did you choose Airflow in the end?
No, not really. So the reason why we adopted Airflow is in a very different way, because most of the some of our analysts are from Facebook, and Facebook has a similar system like Airflow, and that's a history of Airflow, right? Like Max worked on Facebook, and it's a similar system. So it's kind of a very natural thing for them to adopt. So it is not really an engineering-driven decision for us to adopt Airflow. We have a homegrown ETL system that works really well, written in Golang, scaled perfectly well. The moment basically starts from the analyst. The reason is very simple to develop. That's why I mentioned the DSL part of it, right? It's a very simple process. They don't need to learn any system-specific thing. So it's more of a user-driven organic growth of Airflow adoption rather than an engineering-driven adoption. So, sorry.
All right. From Data Girl, you are running all your jobs on a single box. Don't some take ages this way?
Right. So I think there's a misconception. Like most of our tasks are a Spark job or a Hive job that basically executed in a yarn. The job of Airflow to submit the job and wait for the task to either the success state or not. So the unit of execution or the work that Airflow doing is very less. All the jobs runs on either a yarn or any Presto clusters, right? You're just waiting for submitting a job and waiting for the status. So that's why we created the retriable sensors and all sort of a thing. So task can run 1 hour or 5 hours. We can't predict that. So let it retry until you get the state of it. So it's not taking ages.
And Sabira is wondering, according to which criteria do you group jobs in the same DAG?
It depends upon the business need. We don't really have any specific rule you should group the DAGs such a way, right? It's the end user decide. The user decide how do you want to build the DAG. So there is no specific rule for that.
Mm-hmm. From Anonymous, how do you handle the situation in which the scheduler stops working? What do you do to prevent long periods in which the scheduler is not running? How do you find out as soon as it stops?
Right, that's a good question. So, so Airflow has certain alerting, but it will not really give you whether the scheduler is running or not. So what we do here, we collect scheduler logs and feed that into our ELK stack. And we continuously, so in the logs, if you see, you can perform some regex and say how many tasks are created at a particular time. So we feed that metrics, and if certain task is not there is no new task created at a certain point, then we will get a pager alert, hey, Airflow is not scheduling any task. And there is also another metrics in Airflow, which is like the DAG back size. So you can measure how many DAGs, when Airflow executed, it create a DAG back and execute each and every task. So it periodically emit how many tasks that has in the DAG back. So you can also alert based on that. So if the DAG back size is high for a certain period of time, which means Airflow is not able to schedule any task. So we have 2 alerting for that to make sure the scheduler is working.
All right, and I think this will be our last question. From Sabrine, how do you test the DAGs? What data do you test it on, and how do you mock the different data stores?
So we test the validity of the DAG, and we don't test on the actual task. We don't have very testing environment for that. So that's one of the biggest issue with the data pipeline or data engineering. Creating a new test system itself very complex. What point you will create a test pipeline, right? So that's why we added the data quality as part of the lifecycle. So we test on the quality of the data, and we make sure the DAG sanity is perfect. So that's a precaution that we take.
All right. Thank you very much.
Thank you.